Okay, so before we get to our significant figures, we're just going to finish up with our uncertainty. Like we said, the better equipment we have, the better data you're going to be able to record. And you can see there's only 2 hash marks here indicating that there's the 1 milliliter intervals going up from 1 milliliter to 2 milliliters. In the scale on the right, in this scale on the right, you can see that there are more intervals, meaning that's going to have more precise or more accurate results. So the better equipment we have, and that's going to tell us the better equipment, then we are going to have better accuracy. So if we look at our 2 different beakers that we have, if we look at our 2 different beakers that we have, the one on the left, say if we're going to look at both, if we look at both of our graduated cylinders here, you can see that we have our graduated cylinders filled up about halfway between our 2 milliliters and our 1 milliliter. However, since our intervals are going to be a little bit different, we're going to include all readable digits. Our readable digits would be this 1 milliliter, this 2 milliliters, and then 1 estimated digit past. This is where our significant figures come in. So our readable digit is going to be 2 or 1. That's in our ones column. Remember our ones column, our tens column, and then after the decimal point, the tenths, the hundredths, the thousandths. So we're able to read to our ones column. So our readable digit is going to be 1. Our estimated digit, since we're only able to go to our ones column, our estimated digit is going to be in the tenths place. So we'll say that's about 1.5 milliliters and our graduated cylinder on the left. Over here on the right, since we have intervals of 0.2, we're able to more accurately read that. We know that it's going to be about 1. It's in between the 0.4 and 0.6. So it's 1.5, all readable digits, plus 1 estimated. I'd say it's pretty much in the middle. So we're going to say it's 1.50. The difference between the graduated cylinder on the left, we have 2 significant figures, and the graduated cylinder on the right is going to have 3 significant figures. Because we have that 1.5 that we're able to see, it's in between the 0.4 and the 0.6, and then we have our estimated hundredths column as well. If the measurement is exactly between the measurement lines, record it as 0.5. Or generally, the last estimated number will either be a 0 or a 5 due to the small graduations that we have for that. So we end with either a 0 or a 5 in all of our significant figures. If we have something that gives you a digital readout, like a thermometer or a scale, then you need to write down everything you see. I don't care if there's 1 number past the decimal or if there's 7 past the decimal. You write down every number that is given. And our last one, huge note. Huge. Notice it is bolded, it's capitalized. Circle now. If there is a decimal, it is there on purpose. If I didn't want it there, I wouldn't have put it there. And yes, it matters. There's a story about that, and we're going to talk to you about that when you guys are in school and we're doing our lab experiment. We'll talk about that in person. And the last thing, uncertainty in measurements. Uncertainty in measurements depends on the estimated number and is a way of determining how sure one is in the measurement. Example for this, if an object is measured being 37.90 millimeters, it could be technically either 37.85 or could go up to 37.95. There's that fluctuation or the uncertainty that we're going to have. Since it's our last place, we go to the hundredths here. We go to a hundredths here, and there's either a plus or minus of 0.05, 5 hundredths. Even though it's recorded as 0.90, we have that uncertainty here. And again, like I said, we have digital readouts. They do not have implied uncertainty. Those are exact readings taken as well. And the bottom line, the last non-digit number is estimated. So it could be in the range of that plus or minus 5, depending on where we are at. This is where the uncertainty in measurements is established. And in our next video, we're going to talk about our significant figures and how to count them. See you guys then.